All right. So I'm on page 15 of your notes. There we go. So the other type of rational word problem that we deal with is what I like to call the crew problems. So the working problems. Like it's talking about crews working somewhere. All right. Or getting the job done. So these are called getting the job done problems. So let's look at the first problem. One road crew can have a section of highway paved in 12 hours. So one road crew can pave a highway in 12 hours. A second crew working with newer equipment can do the same job in 8 hours. So the same length of highway, but in 8 hours. How long would it take it to pave that same section of highway if both the crews work together? So in other words, if we put those two crews together, how much time would it take them to paint that same amount of highway? All right. Now, obviously, if you think about your answer would be what compared to the two times that were given? Would they be faster or slower? They'd be faster because two crews are faster than one crew. So that means that at the very least, our answer has to be less than 12 and less than 8. All right. So it would be faster. Now, the way you want to think about this is you want to think about how much of the road did they do in 1 hour. In other words, we're kind of creating a rate of how much they did in 1 hour. All right. Because that's how fast they went. So, for example, like I said, if I was driving with the cruise control on, so my speed's constant, and I was going 50 miles an hour. So 50 miles an hour. And I've been driving for 3 hours. How many miles did I drive? 150. All right. So if I told you that I drove at a constant rate and it took me 3 hours and I drove 150 miles and I asked you what my speed was, that's how you figure it out. You divide 150 by 3. So that's essentially what we're doing here. We're finding their speed, so to speak, how much of the road they did in 1 hour. So the first crew, since they could do the whole job in 12 hours, that means that they can only do a 12th of the road, or 1 over 12, each hour. You just split it evenly. We're assuming that they split it all evenly. Now, is that true in the real world? No, because, constant speeds aren't really much of a thing in the real world. But this is all theoretical. All right. Crew 2 could complete the job 1/8 of the road each hour. So essentially, however long they take to do the whole job, for 1 hour, you just do 1 over that number. All right. Now, working together, that means they will complete 1 over t of the job each hour. And t is the time it will take to complete the whole job. So when we set it up, it would look something like this. So 1 over 12 plus 1/8 is equal to 1 over t. So essentially, what we're figuring out is that within this time frame, all right, this is how much time it takes for both crews to work together in 1 hour. That's what this equation represents. It's how long it takes both crews to work together in 1 hour. So if one of them can do it in a 12th of the time, the other one can do it in an 1/8 of the time. If we add those two fractions together, that's how much of the road they'll get done in 1 hour. All right. And that also gives us a good rational equation to solve for the total time, because obviously the total time they took for the whole job is your denominator. So now let's actually look at solving it. So I'm going to rewrite it over here. So I have 1/12 plus 1/8 is equal to 1 over t. Now, since we have more than one fraction on one of the sides of the equal sign, that means we have to use what method for solving? LCD or proportions? LCD. So we got to find a least common denominator. So let's look at what each have and what each don't have. So because there's a t and no other function has a t in the variable, we have to assume that part of our LCD has to have t in it somewhere. Now, let's think about this logically. What is a number? So first off, we need to figure out if 12 and 8 are multiples of each other. So does 12 divided by 8 give you a nice whole number? No. Does 8 divided by 12 give you a nice whole number? No. So they're not multiples of each other, so we need to find a number that both numbers can multiply to. So think about it this way. What's a number that's in common with 12 and 8? That if I multiplied another number to, doesn't have to be the same number, but I can multiply any other number to, and it would give me that number. 24. So 24 would work. Now, if you had issues figuring that out, because least common multiples can be a bit more difficult than GCFs, here's a little trick. So remember how I showed you how you can find greatest common factors in Desmos? You can also find least common multiples. So if you go to functions, scroll all the way down to number theory, the very first one says LCM. That stands for least common multiple. That's the exact same thing as least common denominator. If you click it, and then you type in your numbers. So 8, 12. And it gives you your LCM, which is 24, just like Jasmine said. What's another number that could be a multiple of both those numbers besides 24? So in other words, what's another number that both of these numbers can multiply to at some point that they have in common? 48 will work. You could also do 8 times 12, which is 96. That's an obvious one. I mean, not necessarily. That just happened to be like the lucky thing. So our least common multiple is 24. So my suggestion to you is if you have trouble with least common multiples, at least in terms of the number side of it, use Desmos. So use this trick. Because remember, Desmos is open to you for all your tests, including the EOC. So use it to your advantage. But you just had to know that the t also had to be in there because there was a t in the denominator. So our LCD is 24t. So that means that we have to multiply our entire equation by 24t over 1 so that we can get the denominators to cancel out. All right? So all my denominators will be the same. So 12, 8, and t. And then I have to multiply 24t to all of the numerators, which all the numerators are 1. So what's going to be all my numerators for the new equation? 24t. All right. Now let's look at what happens. So we can do some simplifying now. What's 24t divided by 12? It would be 2t. What's 24t divided by 8? 3t. 24 divided by 8 is 3. And then we bring down the t. And then what's 24t divided by t? 24. So that goes away. So the t's go away. We're left with 24. Now we have a really simple linear equation. So we combine like terms first. So what's 2t plus 3t? 5t is equal to 24. Divide both sides by 5. T is equal to 24 over 5. Now, since we're talking time, let's do it as a decimal. So, in other words, if I do 24 divided by 5, 4.8. So, in 4.8 hours is how long they would take. So, 4.8 hours is how long it would take them to do the whole job if they worked together. So, like I said, these are a little bit easier than the distance ones because you don't really end up with quadratic equations. More often than not, you end up with linear. All right. Any questions on that one? All right, let's do one more, and then we'll move on to the last bit of solving. So, a bathtub can be filled in 6 minutes. Yes. Yes. It takes 8 minutes for the bathtub to drain. If the faucet is turned on, but the drain is accidentally left open, how long will it take to fill the tub? So, if you've ever had a bathtub at home, which I'm assuming most of you guys do, have you ever tried to take a bath but you forgot to close the drain? You weren't thinking about it and you forgot to close the drain, and then you realize and you're like, "Oh, crap." Well, let's pretend that you completely forgot, you walked away from it, and you were trying to see how long it take the bathtub to fill. All right, with that drain open. It takes 6 minutes for the tub to fill if the drain was closed. It takes 8 minutes for the bathtub to drain if the tap is not running. All right. So if the faucet is turned on, but the drain is actually left open, it wants to know how long it takes to actually fill the tub. Because it is possible, even with the drain going, because the amount of water comes in faster than the amount that it drains out. All right. So in reality, these are working against each other, but we can still figure out how much time it takes. So we're going to use subtraction when they work against each other. So let's think about how I would set this up. So let's look at per hour first. So for the tub to fill, or per minute, I should say, because we're in minutes. So basically you do it per whatever the unit is. So per minute, how much of the tub would fill per minute? So it takes 6 minutes to fill the entirety of the tub. How long would it take for it to fill in 1 minute? Or how much would it take? How much would be filled in 1 minute? 1/6 of it. So 1/6 of the tub is filled per minute. How much of the tub would drain in 1 minute? 1/8. So at the same time, how would I set that up? So if I wanted to know how long it would take it would drain and fill at the same time per minute, what would I do? Well, it would represent 1 over t per minute if it was at the same time. They're draining and filling at the same time. But we got to think about this logically. So these two are not working together. They're technically working against each other because think about it. When you're filling a tub, you're adding water. But when you're draining the tub, you're subtracting the water from it. So they're working against each other. The previous problem, the crews were working together. Their work was, being overlapped. Right, it'd be minus instead of plus. But the question is, which one would go first? So let's think about this logically. If we want to know how long it would take to fill the tub, which number do you think we're going to be subtracting, the 1/6 or the 1/8? The 1/8, because that's what we're draining out of it while it's filling. So our function would look something like this. 1/6 minus 1/8 is equal to 1 over t. All right, because we're trying to figure out how much got filled without it. All right. So now let's find an LCD and then solve it. Yes. When Gavin gets back. Well, actually, can you wait because we're about to go on break after this problem. All right. So LCD. Obviously, the LCD has to have a what? A T. There got to be a T in there. But let's use our calculator to find the LCM for 6 and 8. So I'm going to scroll down to LCM, put 6, 8. It's 24 again. So 24T is my LCD. Now I'm going to multiply all of this by 24T over 1. All right. So all of my denominators are exactly the same. But now all of my numerators, if I distribute the 24T to all of them, is now what? 24T. All right. So now I can do some simplifying. So what's 24T over 6 simplified down to? 4T. 24 divided by 6 is 4. Bring down the T. 24T divided by 8, we did that in the previous problem. That's 3T. Make sure it's separated by a minus. And then what's 24T divided by T? 24. Then we just combine like terms and solve. So what's 4T minus 3T? 1T. Then we bring down the 24. And guess what? We're done. It takes 24 minutes to fill the entire tub if the drain was also going. So I think like the job done problems are a little bit easier than the distance and rate problems because again, more often than not, it forms a nice linear equation instead of quadratic. So less work that has to go into it. All right. Any questions on those? So we're not done with notes today just yet because we got to go into the next section, but we'll go ahead and take our 5-minute break just so you guys get a little brain break and we can be refreshed and restarted. So I'm going to start the timer. Go ahead and take your break. Make sure you're back by the time it goes off. All right, guys. So go ahead and pick up the ball. So I'm on page 17, I believe. So yeah, page 17. That's where we're starting at. All right. Shh, shh. So the last little bit of the solving part of both lessons. So this is a continuation of 4.5. Has to do with reasoning about radical and rational equations. All right. So rationals and radicals can connect to each other in certain situations because they both can have extraneous solutions. Sometimes rational equations can turn to quadratics, which you can use radicals to undo. There's a lot of connections to it. So when we look at square root or radical equations plus rational or fractional equations, sometimes the solutions to these equations are introduced as extraneous roots. So we talked about this the other day. What does it mean if it's extraneous? Well, it's a zero in the denominator for a rational function, but in other words, it's a solution that we can reject. Like it would make either a zero in the denominator for a rational. So for rational, it's a zero in the denominator. That gives us extraneous. What do you think it is for a square root? What's the one thing we can't have underneath a radical? We can have zero under a radical. Square root of 0, 0. A negative, because it creates a imaginary number. So if we're trying to solve a solution, if we're trying to solve something, we don't want imaginary numbers. So an extraneous solution would be if we get a negative under the radical. So is what would be considered an extraneous solution, is if we plug it back in for x in the original, it gives us either a negative under the radical if it's a radical equation, or a zero in the denominator if it's a rational equation. So we're going to look at some basic properties of equality. So the addition property is if you have a equals b and c equals d. All right, so a and b are the same numbers, c and d are the same numbers. That means that a plus c would be equal to b plus d. So like, for example, if this was 1, so a is 1, that means b is 1, because 1's equal to 1. And let's say c and d were both 2. Is it not true that 1 plus 2 is the same thing as 1 plus 2? Is that true? Yes. That's why that's a true statement. All right. Multiplication property is very similar, just with multiplication. So if you have a and b and c and d, a times c is the same as b times d. So again, using the same 1 and 2 examples. So if this was 1 and these are 2, is it not true that 1 times 2 is the same thing as 1 times 2? Yes. So that's why that one works. Now we're going to use these two properties to justify the solution of an equation involving a square root. So we're going to look at these different properties. So they already worked out the steps, but we're just going to say, okay, it's true because of this property. That's why it's true. So the first thing that they did was that so this is the original, x equals square root of x plus 6. So the first thing that they do is multiply one side by x and the other side by the square root of x plus 6. What property allows them to do that? The multiplication property. Because let's say that x was a and b and x plus 6 was c and d, or vice versa, that's still the multiplication property. We can do that. We can multiply the same thing to different things because that's the same thing as squaring it. It's totally fine if we square it. Because essentially what they're doing is, if you have x times x, what's that the exact same thing as? X squared. If you have square root of x plus 6 times square root of x plus 6, what's that the same as? Nope, it's the same thing as the square root of x plus 6 all squared. Because that's what it means to square something. Now, the next thing that they do is that they get that x squared equals x plus 6, and they just simplified. All right? Now, they then moved everything to the other side and factored. All right, so what they did here, because it's hard to tell what they did, is that they subtracted the negative x from both sides, so that canceled. They added, they subtracted the 6 to both sides, that canceled, and they ended up with this. All right. So that property is just inverse operations. They're just doing inverse operations to get to sorry guys, got gunk in my throat. So they're just using inverse operations or opposite operations to move things over to the other side, so we get one side equal to 0. They then factor this expression to be x minus 3, x plus 2. And then they set both of them equal to 0. What property allows us to set both of these equal to 0? Yes?
X minus 3 equals 0.
Yeah, because these are the two factors. So we set both of them equal to 0.
No, I'm saying it wouldn't end on x squared, it would end on x minus 3.
What are you talking about for this one?
Yeah. The one that we said was inverse operations.
Because you subtract x, so this can't combine. So this would be x squared minus x. Subtract the 6. This would be x squared minus 6. So it gives us this trinomial.
Well, no, I know that. I'm saying it ends, the problem that they're doing up there ends on x minus 3.
Because they factored it.
Yes, I know, but it's still the inverse operations.
They're factoring. So this right here, that's when they did big X. So they did big X to get from here to here. All right. So they factored it. All right. Then from here, they took these two factors, set them both equal to 0. They can do that based off of the addition property. And then they solved each individual equation. So their two answers were this right here. So x equals 3 or x equals negative 2. Now, we need to check to see if either one of these two solutions is an extraneous solution for our original. So we're going to plug x equals 3 and x equals negative 2 back in separately into x equals the square root of x plus 6. Because remember, if it's extraneous, we would not be able to have what under the radical? A negative. Now, we can't have a negative under the radical. What else has to happen? If we have variables on both sides of the equation, they have to do what? Don't they have to equal each other? So if I have a variable on this side of the equation and a variable on this side of the equation, not only can we not have a negative under the radical, we also need to make sure that both sides of the equation equal the same number. So I will end up with something like 4 equals 4 or 1/2 equals 1/2, something of that nature. Equal the same number. That's another way that you can have an extraneous solution is if they don't equal the same number, but we got it when we solved it. All right. So I'm going to plug in 3 first for both x's. So I'm going to plug it in here and here. So I have 3 is equal to the square root of 3 plus 6. All right. So if I simplify, I get 3 is equal to the square root of 9. Well, what's the square root of 9? Not just 3, but positive or negative 3. So this would be 3 is equal to plus or minus 3. Now, since the positive is in that expression, this is a solution, all right? Because the plus or minus contains the type of 3 that we want, all right? But on the other hand, if we had negative 2 equals, well, actually, let's leave this as just positive 3. We'll just leave that as positive 3. The square root of negative 2 plus 6. What's the square root of negative 2 plus 6? So negative 2 would be equal to the square root of 4, which is negative 2, which is equal to plus or minus 2. Yeah, I'm keeping the plus or minus. So, does it satisfy? Yes or no? Does that plus or minus 2 include negative 2? Yes, so it does satisfy. So in this case, we don't have an extraneous root. What they're trying to get at is that if we just solved it like this and we just assumed that it was the positive, the negative 2 would technically have been the extraneous root. However, if you went back and plugged it into x squared equals x plus 6, it would have still gave you the exact same thing, and it would not have been an extraneous root. So remember, if you're doing anything with radicals, if you take a radical of a number, make sure you throw that plus or minus in front of it, because that can change the difference between if it's extraneous or not. All right. The extraneous root gets introduced because the operation of squaring is irreversible, meaning that once we've squared, we cannot know the original quantity. All right. So what I mean by that is that let's say I did 3 squared, all right, and I got 9. But then I just threw the 9 at you and I told you to give me the number that I used to square to get 9. Well, what are my 2 options? What number squared gives you 9? 3. And what's the other number?
2.
What other number squared gives you 9? Negative 3. So that's why the original quantity is unknown, because it could be either 3 or negative 3 to give us 9 if we squared it. We don't know which one we used. So we have to account for both. All right. Now, let's consider this relatively easy equation. So we're going to solve this equation using the reversible operation of division. So in other words, if we did negative 2x equals 6, we would divide by negative 2. X would equal negative 3. But now we're going to solve this equation by squaring both sides. And what extraneous root has now been introduced? So in other words, we now have negative 2x equals 6. But what they want us to do is they want us to square both of these sides. So what's negative 2x squared? Positive 4x, because negative 2x times negative 2x is positive 4x what? Squared. What is 6 squared? 36. So we're going to solve by taking a square root. So I got to get the x squared by itself. I need to divide by 4 first. So if I do that, I get x squared is equal to 9. I take a square root of both sides. X would be equal to what? Plus or minus 3. So, same equation, we just did a different process. So what is the extraneous solution here? So this is what we want originally. This is what we got if we did a different method. So what's the extraneous solution? What's the one that we can reject? Not the plus minus, but if I broke apart the plus minus, so I have positive 3 and negative 3 for x, which one can I reject? The positive 3, because I want my answer to equal negative 3. So 3 is extraneous. So if we go back to the previous problem, our extraneous solution here, extraneous is negative 3, because we wanted positive 3 originally. And our extraneous here is positive 2, because we wanted negative 2 originally. So that's what it means by throwing it out. Because remember, whenever you take a square root, it's technically plus or minus whatever that square root is. All right? The extraneous solution is the one that we don't want, whether it's the positive side or the negative side. As well as, if we solved it and it turned out it gave us a negative under the radical. Either way. Any questions on that part? All right, let's keep going. So now we're going to look at it from a rational perspective. So in the case of solving square roots, we would square both sides to remove the square root, because that's the opposite of a square root. It's a square. And we introduce solutions that do not make our original equation true because of squaring it. So let's investigate why that happens with rational equations. So remember, with rational equations, that's when we can cross multiply. That's also when we can do LCD. So all these steps below, they're using the LCD. So they're using the LCD method to solve this equation. Now, we could solve it by cross multiplying, and that would eliminate the need for extraneous solutions sometimes. But if they do LCD, sometimes that does introduce extraneous solutions. So they determined, based off of what we started with, that our LCD was x minus 1 times x plus 3. So they were multiplying x minus 1 times x plus 3 over 1 to both sides of the equation to get rid of the fractions. And that's the multiplication property. They then did all their cross outs. So they didn't actually write out what they looked like after they multiplied them through, but this is what they would get after crossing out. So this is after crossing out. Then they FOILed it and distributed to get the next part of the equation. And then they started solving. So they subtracted the x squared and the negative 3x to both sides to get one side equal to 0. And then they did to the same side. So again, that's by inverse operations. They then factored this resulting polynomial to get x plus 3 times x minus 2. They set both of those factors equal to 0 by the addition property. And they got this as their answer, x equals negative 3, x equals 2. So if I plug back one of those answers into my original equation in the denominator specifically, which one of those two answers would give me a 0 in one of the denominators? So I do have an extraneous solution here of one of the highlighted blue expressions. Which one do you think it is? So in other words, if I took these two answers and I plugged them individually back into the denominators of my original equation, which answer would make one or both fractions have a 0 in the denominator? So the negative 3, good. So the negative 3 in this case would be our extraneous solution, because if we plugged it in for this x here, what's negative 3 plus 3? 0. That will give us a denominator of 0. So our extraneous solution, the extraneous solution is x equals negative 3. And again, that's because if we plugged it back into our original denominator, so if we did x times 3 minus 1 equals x times, or negative 3 minus 1 times negative 3 plus 3, we would get, or 2x plus 6, sorry. We would get x over negative 4, which that's fine, is equal to 2x plus 6 over 0. This one is where it's not fine. That's what makes it extraneous. If we plug the 2 in, it won't matter because 2 minus 1 is 1, so that's fine. 2 plus 3 is 5, so that's fine. But the negative 3 is extraneous in this case because it makes that denominator 0. Now, the extraneous root is arising because multiplying both sides of an equation by anything containing a variable like those two factors that we did is, again, irreversible due to the fact that we could be multiplying both sides by 0. So we'll investigate this again by solving this last equation. So this very, very simple equation, 5x is equal to 15, which if we solved it, we would know that the solution is only x equals 3, because positive 5, if you divide it into 15, gives you positive 3. But now we're going to do something a bit different. We're going to solve this equation by multiplying both sides of the equation by x minus 1. So in other words, I'm going to take this 5x and multiply it to x minus 1, set equal to 15 times x minus 1. I'm going to multiply both sides of my equation by x minus 1. So I'm going to distribute on both sides. So I get 5x squared minus 5x is equal to 15x minus 15. So then I'll subtract some stuff over. So I'll subtract the 15x and add the 15 to both sides. So subtract the 15x, add the 15. That goes away. I get 5x squared minus 20x plus 15 is equal to 0. And then I'm just going to do a very quick factor. So there's a GCF of 5. I take that out, I get x squared minus 4x plus 3. So if I factor equals 0, so if I eliminate the GCF and factor it, I would get x minus 3 times x minus 1 equal to 0, which if I then set both of them equal to 0 to solve, I get x equals 3 and x equals 1. Those are my two solutions if I did it that way. But which one's extraneous now? What does 5x equals 15 have to equal to? 3. So we're using the exact same equation, but we just multiplied the same thing to it. But we got an extra number. So which one of those two solutions is the extraneous one? X equals 1. This one right here is extraneous. So we only want it to be x equals 3. Because if you think about it, if I plug in 1 in for x, 5 times 1 equals 15. Is it true that 5 equals 15? No, that's why it's extraneous. It makes our equation not true. In math, as long as you multiply one side to the other, or you do the same operation on one side that you do to the other, like squaring it, that is completely fine in math when solving an equation, as long as you do the same thing to one side as you do to the other. But sometimes if you go that route, it can screw you up and give you an extraneous solution. So my suggestion to you, always check for extraneous solutions. So especially with rational functions, take the extra minute, plug it back into your rational equation, and not the entire rational equation, just plug it back into the denominator if it has an x there, and see if it equals 0. If it does, it's an extraneous solution. All right? Any questions on that? So that's all that part of the lesson was talking about, was just extraneous solutions, and just be careful about watching out for them. All right. So you guys got about a solid 30-ish, 25-ish minutes left of class. So remember, you should be able to finish your 4.5 Delta Math now if you haven't already. And there's also a 4.4 quizzes that we didn't get to yesterday. So make sure you do the quizzes for 4.4. That's all the word problems. There's only like 10 questions. You get 2 attempts on it, and it's for mastery. So try your best on it. And then the Delta Math, that'll be due tomorrow by midnight. It's either tomorrow or tonight. I can't remember. So you guys got plenty of things you can work on. So go ahead and get to work. Yes, sir. Yeah. And I'll go ahead and post the exit ticket as well.